Have you ever wondered if time travel is possible? It's a question that has fascinated humanity for centuries, sparking countless stories, movies, and theories. But what if I told you that time travel isn't just a figment of science fiction, but a reality that is happening right now? What if I told you it's already happening? Yes, you heard that right. Time travel is not just a concept confined to the realms of imagination. It's a phenomenon that astronauts experience every time they venture into space. Astronauts orbiting Earth are experiencing time slightly differently than us. This isn't just a minor difference. It's a measurable effect that has profound implications for our understanding of time and space. It's not science fiction, it's science fact. The concept of time dilation, which is a cornerstone of Einstein's theory of relativity, explains how time can pass at different rates depending on various factors. The universe is a strange and wonderful place, and one of its most mind-bending aspects is the concept of time dilation. This phenomenon occurs because the fabric of space-time itself is warped by gravity and speed. This phenomenon, predicted by Einstein's theory of relativity, means that time can actually pass at different rates depending on your speed and the gravitational field you're in. For instance, the faster you travel, the slower time moves for you relative to someone who is stationary. In the vast expanse of space, where gravity warps the fabric of space-time, the seemingly simple act of aging becomes a fascinating puzzle. Astronauts on the International Space Station, for example, age just a tiny bit slower than we do on Earth. Join me as we unravel the mysteries of time and explore how astronauts become time travelers, experiencing the universe in a way we can only dream of. We'll delve into the science behind this incredible phenomenon and discover what it means for the future of space exploration and our understanding of the cosmos. So, are you ready to embark on this journey through time and space? To understand why astronauts age slower, we need to wrap our heads around Einstein's theory of relativity. One of its most groundbreaking concepts is that time is not absolute. It's not a constant ticking away at the same rate for everyone, everywhere. Instead, time is relative. It's affected by both speed and gravity. Imagine time as a flowing river. The faster you move through space, the slower you move through time, like a boat going against the current. Similarly, the stronger the gravitational pull you experience, the slower time flows for you, as if the riverbed itself is deepening. Gravity, according to Einstein, isn't just a force. It's a curvature in the fabric of space-time. Picture a bowling ball placed on a trampoline. The ball creates a dip, a gravity well, in the fabric. Now, imagine rolling a marble across the trampoline. Its path will curve as it passes near the bowling ball, affected by the dip in the fabric. This is similar to how gravity influences the path of objects, including light, in space. The stronger the gravity, the deeper the well, and the slower time flows for objects caught within its pull. One of the most famous examples of time dilation involves astronauts on the International Space Station, or ISS. The ISS orbits Earth at incredibly high speeds, experiencing a slightly weaker gravitational pull than we do on the surface. Because of these factors, astronauts on the ISS actually age a tiny bit slower than people on Earth. It's a minuscule difference, but it's measurable. When astronaut Scott Kelly returned from his year-long mission aboard the ISS, he was a few milliseconds younger than his twin brother, Mark, who had remained on Earth. Section 5. Satellites and slowed down time. Proof in orbit. The effects of time dilation aren't limited to astronauts. Our everyday lives are influenced by it too. Take GPS satellites, for example. These satellites orbit Earth at high speeds and rely on incredibly precise timekeeping to provide accurate location data. However, because of their speed and altitude, GPS satellites experience time slightly differently than we do on the surface. To compensate for this, their internal clocks are calibrated to run slightly slower. If they weren't, our GPS systems would be off by several miles each day. Section 6. A matter of perspective. Time is relative. It's important to remember that time dilation is all about perspective. From an astronaut's point of view, time is flowing normally. They don't feel like they're aging slower. It's only when we compare their experience to someone in a different gravitational field or traveling at a different speed that we see the difference. It's like two people walking at different paces. To the person walking slower, time might seem to be passing normally. But to the person walking faster, the slower walker appears to be moving through time at a slower rate. Section 7. The nitty-gritty. How much slower do astronauts age? You might be wondering, how much slower do astronauts actually age? It's a fascinating question that delves into the realms of physics and the nature of time itself. The answer depends on their speed and the strength of the gravitational field they're in. This concept is rooted in Einstein's theory of relativity, which tells us that time is not a constant and can be affected by gravity and velocity. For astronauts on the ISS, the time difference is very small, on the order of milliseconds over a 6-month mission. This is because the ISS orbits Earth at a speed of about 28,000 kilometers per hour, which is fast, but not nearly fast enough to create a significant time dilation effect. However, the faster an object travels and the stronger the gravitational field it's in, the more pronounced the effects of time dilation become. This means that if we could build spacecraft that travel at a significant fraction of the speed of light, the time dilation effects would be much more noticeable. If we could travel at speeds approaching the speed of light or venture close to a black hole, the time difference would be much more significant. Near a black hole, the gravitational field is so strong that time would slow down considerably for anyone close to it. This means that while only a few hours might pass for the astronaut, years could pass for someone far away from the black hole. This fascinating phenomenon shows just how strange and wonderful the universe can be. Section 8. So, can we time travel? The big question. The concept of time dilation might make you wonder, can we build a time machine and travel through time at will? Time dilation, a phenomenon predicted by Einstein's theory of relativity, occurs when time moves slower for an object in motion compared to one at rest. This has been observed in experiments with atomic clocks on airplanes and satellites. While time dilation is a real phenomenon, it's not quite as simple as hopping in a DeLorean and gunning it to 88 miles per hour. In movies like Back to the Future, time travel is depicted as a thrilling adventure, but in reality, the science is far more complex and less dramatic. The time differences we're talking about, even for astronauts, are incredibly small. For instance, astronauts on the International Space Station experience time slightly slower than people on Earth, but the difference is just a fraction of a second over the course of a year. We haven't figured out a way to manipulate gravity or travel at speeds close enough to the speed of light to make noticeable jumps in time. Theoretical physicists have proposed concepts like wormholes or cosmic strings, but these remain speculative and unproven. However, the fact that time dilation exists at all opens up fascinating possibilities and fuels our imagination about the nature of time and the potential for future discoveries. Could we one day harness this phenomenon to explore distant galaxies or even revisit moments from our past? The quest for understanding time continues to inspire scientists and dreamers alike, pushing the boundaries of what we know and what we can imagine. Section 9. Explore more. The universe is your oyster. The universe is full of mysteries waiting to be unraveled. Time dilation is just one example of the mind-bending concepts that govern our cosmos. What other space phenomena pique your curiosity? Do black holes really distort time, or is time travel just a figment of our imagination? Share your thoughts and questions in the comments below. Section 10. Join the journey. Subscribe for more cosmic adventures. The exploration of space is a never-ending adventure, and I invite you to join me on this journey of discovery. Subscribe to my channel for more fascinating insights into the universe, from the mysteries of black holes to the search for extraterrestrial life. Together, let's unravel the secrets of the cosmos and expand our understanding of our place in the grand scheme of things.